Assalamualaikum and hi. My name is Puteri Nurnajla Raihan binti Abdul Razak from Group 25 Multivision Construction and Consultancy. So for Integrated Design Project 3, IDP3, I'm going to present my minor slides which is consists of Road Department, Structural Department, Geotechnic Department and Drainage Department. Since my major is Planning and Scheduling Department. So for road department, we actually need to design the road at the selected area which is located at Cameron Highland Pahang. So for the road design, we first need to identify the type of project, design road group depending on the function such as arterial or collector, estimated annual daily traffic and end of design life, determine design standard for rural and urban, and design the traffic and road. The area consists of three buildings which are hotel, condominium and business lot. The proposed level calculated from IDP1 previously for hotel is 1450 to 1453, condominium 1445 to 1453 and business lot 1450 as we can see from the figure on the left. From the figure on the right is the results calculated that shows there will be three different phases for the traffic signal from east, west and north, which is the purple color, the blue color and the red one. So then from the table on top, we can see that after calculation and assumption for amber period which is 3 seconds, all red period 2 seconds and lost time 2 seconds, the total cycle time is 120 seconds for phase 1, 2 and 3. Then for the figure below here, we can see that the signage that we have assigned in certain location is depending on the usage as well as the geometry to prevent operational problems. This is the signage that we have selected and placed in the three different buildings on the road. So for the structural department, which is focusing on the designing of structural components of the two-story Sekolah Hidayah Preschool, we need to propose a suitable design for column, foundation and staircase by using suitable material for structural component. And we choose Orion software for this structural design except for staircase since it is need to be manual calculation. So as we can see from the table on the left is the first one is we need to take 50 years working life. We assume to take 50 years working life of the building as normally we'll take 50 years working life for building construction. And then XC3 for exposure class for superstructure and XC2 for substructure which is footing since it is in contact with water for a long term. And then a fire resistance of 1 hour since it is a small building. Staircase, we use grade 25 stroke 30, while column foundation we use grade 35 stroke 45, and the staircase we use lower grade than column and foundation because it is a non-structural member and we can save the cost of material. And for the concrete cover, we take 35 mm for column, 50 mm for foundation, and 25 mm for staircase. So from the figure shown here is actually from Orion. This is the size of concrete used for the structural member. And lastly, a detailing and drawing for all the proposed column, foundation and staircase needs to be shown. And this is important, and this department is important because it is to design a building to prevent wastage and material used during construction, especially for a lower strength member, and also to prevent failure when the building being used. And then for the Geotechnic department, we were given 4 different borehole, which is borehole 2, 4, 6 and 8 for our group. So for this case, we choose deep foundation because shallow foundation cannot support the heavy load transmitted. Firstly, we need to extract all the data which include the soil consistency and SPTN value from the deep boring log and interpret into a soil profile. So from the example here, at the borehole 3 and borehole 5, there is a clay and sand type of soil in that area. And then we need to find the soil parameters such as unit weight, cohesion, friction angle, unconfined compressive stress, and adhesion factor. And then determine the soil bearing capacity from the end bearing and shaft resistance. So from the soil bearing capacity, we can calculate the number of single pile and group pile with the axial load from the structural department. And lastly, do a checking for the elastic settlement as shown in the table here, which is the final results for the pile foundation design for my group. And this is important to design the pile foundation, especially when constructing a hull building with high load. And lastly, for the drainage department, we need to design the drainage network and catchment area. And for the drainage design, a rational method is used, and for the detention pond volume estimation, we use rainfall hydrograph method (RHM). For rational method, we need to determine the average rainfall intensity ARI, runoff coefficient, drain size, overland flow time, channel flow time, time of concentration, peak flow, and check the capacity of the proposed drain. While for the detention pond volume estimation, we need to find the pond outflow limit, pre-development discharge, post-development discharge, preliminary estimation of the required pond volume. So as we can see from the figure on the left, is the blue one is actually the primary drainage, the green one is the secondary drainage, the yellow color is the catchment boundary that we have decided, and the circle here is the drainage junction for different parts. And then from the graph here, we can see that the estimation pond required is 990 meter cube, since the highest storm duration is in 18 minutes. This design is important to prevent overflow and flood, especially during rainy days. And this is all from me. Thank you for listening and have a good day.